With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us solve this question. The question says that the incorrect order is, in this question we are given four options A, B, C and D. And in first three options A, B, C, we are given some order. We have to find out the incorrect order. Now in option A, it is given that the third ionization energy of manganese is greater than iron. We have to find out whether this order is correct or not. So let us see. If we talk about manganese, it has atomic number 25 and its configuration is argon 3d5 4s2. Right. So when it loses two electrons, suppose it loses two electrons, that two electrons will be lost from 4s, right? So its configuration will be argon 3d5 4s0, right? So two electrons are already lost. For the removal of third electron, there is requirement of some energy, and that energy will be third ionization energy, right? So ionization energy is the energy required to remove the electron from outermost shell, and here we have third ionization energy means energy required to remove the third electron. Two electrons are already lost, right? So when manganese 2 positive ion, it will lose one electron, then it will form Mn3 positive, and this third electron will remove from 3d orbital. So in this case, the ionization energy will be third, right? So if we talk about now iron, iron atomic number is 26, so its configuration will be argon 3d6 4s2. Right. So here when iron remove two electrons, so its configuration will be argon 3d6 4s0. Now the third electron will be removed from 3d orbital. Right. So when iron Fe2 positive will lose one electron from 3d orbital, then it form Fe3 positive. So in this case, the energy which will be required is ionization energy 3, right? So now you see, in case of Mn2 positive, the configuration is 3d5, right? In 3d orbital, we have 5 electrons. So 3d orbital is half filled, and half filled orbitals are stable. Half filled orbitals are stable. If you see in Fe2 positive, we have configuration 3d6. Here in 3d orbital, there are 6 electrons. 1, 2, 3, 4, 5 and 6. Right. There are 6 electrons. Now in Mn2 positive, the 3d orbital is stable. So a large amount of energy will be required to remove the electron. But in Fe2 positive, we have 3d6 configuration. And after losing one electron, we get Fe3 positive, in which there will be half filled orbital. There will be 5 electrons in 3d. So after removal of electron, we are getting stable configuration. So here the amount of energy will be less. Removal of electron will be easier. So it means the ionization energy 3 in case of manganese will be greater than the ionization energy 3 in case of Fe, right? So the given order is correct. This is true. So this is not incorrect. So this option will be wrong. In option 2, it is given chromium second ionization energy is greater than manganese. So let us see, we have chromium. Now chromium atomic number is 24, so its configuration is argon 3d5 4s1. So when it will remove one electron, it forms chromium positive and its configuration will be argon 3d5 4s0. Right. So here the second electron will be lost from chromium positive. So when it will remove one electron, it forms chromium 2 positive. Right, so the energy which will be required for this process will be ionization energy 2. Now in chromium positive we have 3d5. We have 3d5. So in outermost shell we have 5 electrons and it is stable configuration. So a large amount of energy will be required to remove electron from chromium positive. Now if we see manganese, the atomic number of manganese is 25 and its configuration is argon 3d5 4s2. So when it will lose one electron, it forms Mn positive. Its configuration will be argon 3d5 4s1. So the outermost electron will be lost from 4s orbital, right? So when Mn positive will lose one electron, it will form Mn2 positive. Right. So here in Mn positive, we have 3d5 and 4s1. When one electron from 4s orbital will be removed, the configuration of Mn2 positive will become 3d5, which is half-filled configuration and it is stable. So in this case, the energy required, that is ionization energy 2, that will be less in comparison of chromium, right? So here ionization energy 2 in case of chromium will be greater in comparison to ionization energy 2 of manganese. So from the option, this is the correct order. This order is absolutely true. So this option is wrong. In C, it is given copper 1 positive aqueous is greater than copper 2 positive aqueous stability order. Now, basically, the stability order of the ions in aqueous solution depends on the hydration energy. It depends on the hydration energy. More will be the hydration energy. More is the hydration energy of the ion. More strongly the ion will bond to the water molecules. So if we compare the hydration energy, if we compare the hydration energy, then hydration energy of Cu2 positive is greater than Cu positive in aqueous form. In aqueous form, right? Because in Cu2 positive, due to greater charge, the size is small and has greater charge density. Greater charge density. So it bonds strongly with the water molecules. That is why the energy which will be released when copper 2 positive ion will be hydrated, that energy will be larger in comparison to Cu positive ion in aqueous solution. Also the Cu positive ions, they are not stable in aqueous form as they disproportionates in aqueous form. In aqueous form, Cu2 positive ions, they disproportionates and from here we get Cu2 positive ion and copper, right? So Cu2 positive ions are more stable in aqueous solution. Now in the option C, it is given reverse order. So this order is wrong. This order is false. So here this is the incorrect order. So this will be the correct answer. Option D will be wrong. So option C is the correct option. So option C is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.